Well, good evening, everybody. Well, my name is Paul Servatka. I'm the president of the Chicago AMS, and I'd like to welcome everybody here to this winter kickoff. I thought it was going to be a fall kickoff, but we're just going to skip winter, go right to fall. I want to skip winter and go right to spring. How about that? Ron Stens, the other professor here, I think is the reason for this cold weather, so please take it up with him if you don't like it. Do we have any forecasters here? What's the latest? You guys are going 1 to 3. Pachota, what are you saying? 5 west of Route 47. Okay. Do I hear 6 inches anyplace? It's going to be fun. Now, what is the record amount of snowfall for the month of October? 6.3 at Midway? At O'Hare. The official one. Okay, so we could be close to getting that. 3.8 for the daily record. So it's crazy. Normal high is 57 degrees. So a little bit cold. I'd like to introduce the new vice president, Sam Augustin. Back there, Sam, if you could say he's the vice president. And Patty Wentraba, the absolute bulwark of this organization, is our treasurer. So are we going to give a treasurer report? Do we normally do that? You want to just kind of, here, I'll bring the mic up for you. So this is an official meeting now.
The only activity we've had is just a balance is $2,648.40.
Awesome. So those of you who are in the community, we really hope that we're trying to build the community up a little bit more. We have meteorologists kind of scattered around the Chicago area, and I'm hoping that we can get some more people coming here with some commitment. I mean, we're bringing some really great people out, and I hope that continues. The dues this year are going to be $20, and you can give a check or cash to Patty, and that would be great if you could. If you're a student AMS from the College of Dupage, where are COD students here tonight? The student group is $15 a year, and then you become a member of the Chicago AMS as well. So you can put that as something on your resume. We do have, Jacob, you want to introduce our officers for that?
Not necessarily. Hi, I'm Jacob Fisher. I'm the president of the student chapter of the AMS here at COD. Our vice president is Nick right there. Nick, you can stand up. Anna is our treasurer right here next to him, and Marianne, our webmaster right here.
So we hope that you will participate of that. How many people do we have from NIU come out today? I see a big contingent up front, and your professors over there looking at your names. Good. We have some Valpo people. A couple of Valpo people coming out. And the rest of you are my students or Ron's students? Anybody else from other regions, student-wise? Oh, good. Well, welcome. This is the official kickoff. Just to give you guys some indications of what's going to be happening this year, we are still looking to line up some speakers. We're going to try to do at least one more meeting this fall term. In January or February, we're going to set up a meeting, and we are going to do a really cool thing. Last year we had Marty Isis came and talked about flight control and working for United Airlines. We have a bunch of people in the industry, both as observers at airports, as forecasters for airlines, who are working along those lines. So we're going to have a big aviation event. We're going to have it at Lewis University, and Rick DeMaio will kind of help host that. He does a lot of forecasting for the aviation program. So if anyone's interested in aviation meteorology, this is a great one to do. I'll be moderating a discussion, so it won't be a typical talk. I will have a list of questions, and there'll be an open discussion from different perspectives and observing, forecasting, looking at flight services, and some pilots who will be talking about how it impacts their stuff. That'll be a big, fun one. We're also probably going to have an end-of-the-year banquet. And we're trying to get somebody from the National Hurricane Center to come out here. They owe us, and we haven't had a good tropical talk for a while. So if anybody else has any other people who might be interested, we are looking at some stuff that comes out of Argonne. national labs, trying to get some varied topics. So if you know of somebody who's interested in talking or you want to talk, come talk to me afterward and we'll take care of that. So we'll try to communicate with you. It has come to my attention that we are trying to get in touch with you. We do have email that we send out information, and we also have our Facebook group. So how many people for the Chicago AMS got their stuff from the Facebook group? How many of you got email? Okay, so a little split. If you don't have email, send an email to me and I can add you to that list, sirvatka@gmail.com, gmail.com, Sirvatka, Sirvatka. So we can go ahead and do that. Okay, without any further ado, it's my privilege and pleasure to introduce Dr. Patrick Marsh from the Storm Prediction Center. Patrick is a wonderful computer programmer. His experience, he went to the University of Arkansas as a physics and math major. Woo, math. And then he ended up getting his master's and his PhD from the University of Oklahoma. And he's been working since the early 2000s at the Storm Prediction Center. He was originally with the Techniques Development Unit. He's done a lot of work on the forecasting operations side of it, and now he's moved up into management, and he still misses forecasting, and he still wants to work those shifts. He is the branch chief. The Storm Prediction Center is broken up into two components. It is the operational side, where you have a branch chief working under Dr. Russ Schneider, who's the manager of the entire office, and that's the operational side. And then you have the science and support side, which is some of the techniques development unit and the science support and programming and all sorts of stuff. And his talk is going to be, what is it? It's
a lot. We're going to cover a lot of ground.
It's going to be a lot of stuff, but like how Python ruined my life, which I think is awesome.
Yeah.
That was the side talk of this. So without any further ado, Dr. Patrick Marsh.
So I was asked to give this talk, and I think we originally tried to schedule it for earlier in the month, closer to, I think, October 1st or 2nd, and then that didn't work out for me. And then we tried to schedule it around October 15th and 16th, somewhere in there, and that didn't work out. And part of that frustration and trying to find the time because of my schedule is what ultimately led to the talk title that I chose, which was How Python Ruined My Life. And the reason for that is when I was in graduate school, I developed a lot of skill sets in programming and taking very complex data sets and breaking it down, analyzing it, and then communicating that information in a very coherent manner. And I got really good at it. It ultimately directly related into me getting into a really sweet gig as a graduate student where I was the liaison to what's known as the Hazardous Weather Test Bed at the Storm Prediction Center and National Severe Storms Laboratory, which kind of allowed me to work with researchers from all across the world. And in doing that gig, I got invited to give a presentation in Wiener Neustadt, Austria, to the European Severe Storms Laboratory, where they actually flew me out for a week. And so, I mean, I was very thankful. It was great. I was riding high, doing a lot of this programming stuff. It directly landed me my first job at the Storm Prediction Center. Through my own, and we'll get into some of this, through my own naive tendencies, I decided, you know what, if I just get to the next level up the chain, it'd be really awesome, it'd be great. And the next thing I knew, my schedule is full of meetings and PowerPoints and Excel spreadsheets and budgets and personnel and things like that. And I asked myself, what on earth am I doing? I can't even go give a science talk without the headache of trying to schedule it because of all the meetings that I have to go through. So it was a particularly dark night, and I was like, you know, Python ruined my life. And so that became the joke. And it's very tongue-in-cheek. There's a lot of true elements to it. By no means, through anything I'm going to say tonight, do I want to come across as that I don't like my job. I love my job. In fact, believe it or not, when I leave here tomorrow, I'm going to go back, I'm going to take my kids trick-or-treating, And I'm going to be sleeping all day Friday because I'm working midnight shifts Saturday and Sunday. So I'll get to work midnight. And it's one of those, I know that I hear some groans. As a manager, let me tell you, working midnight shifts is fantastic. Because when the weather's quiet, you can finally get caught up on all the other stuff that you can't do when you're in meetings all day. So, productivity time for the win. So what I kind of want to do is I've got two talks that I'm going to pull from, and this is kind of embarrassing on my part. Again, Python ruined my life. I literally did not have time to take slides that I already had from two separate presentations and put them into a single presentation. I will, if we want to talk when I'm not mic'd up later, I can kind of tell you some of what is going on as to why I'm stretched extremely thin right now. But suffice to say that I'm extremely busy. And we're going to touch on some of that and the things that got me to where I am in kind of like a story fashion. And I hope to really interact with the students on some of this about the saying the grass is always greener. It's true. And so we'll talk about some of that. But then I've also got some sciencey stuff that we're going to go over, spread over two different presentations. One is more on statistics. I love statistics, fair warning. So we're going to talk a little bit about statistics and why things may come across the way they are. And then we're going to flip and talk about things where, did you know that the Storm Prediction Center actually predicts tornado intensity? We just don't do it explicitly. Our forecasters didn't even know it either until we proved it to them. So we're going to talk about that as well. And so with that, let's see if I can break this. All right, so a little bit about me. Here's the public bio on our Storm Prediction Center website. It's a little outdated. This is when I was the warning coordination meteorologist, which is what I had before I became the science branch chief. And so you can go to the spc.noaa.gov/staff and got profiles from a lot of the people at the Storm Prediction Center. You can learn more about their background. True story, one of our IT specialists, who is by all accounts internal and external, the reason why the Storm Prediction Center thrives, because he's so talented at what he does. Turns out that he was a drill sergeant in the Taiwanese army. He's the most soft-spoken guy I've ever met. And you can learn about stuff like that from the staff bios. But, so the real me. In the third grade, I answered one of those questions that teachers give you that says, what do you want to be when you grow up? And I, in third grade, wrote that I wanted to be the director of the National Severe Storms Forecast Center. How many third graders do you think would know what the National Severe Storms Forecast Center was? I was rather unique even back in third grade. In the 11th grade, I was asked by a local TV station to write a story titled The Makings of a 21st Century Weatherman. It was designed to be offset by a gentleman who'd worked as a meteorologist in the government for 50 years as he was retiring, as a contrasting, looking ahead and looking as a retrospective for the turn of the century. And in that article, I wrote the quote that is highlighted, I want to become the head of either the Storm Prediction Center or the National Severe Storms Laboratory. I at least started to branch out a little bit. So the Storm Prediction Center moved from Kansas City to Norman, Oklahoma in 1996 and basically through 95 through 97. It was a piecemeal transition. Prior to that, it was the National Severe Storms Forecast Center. So going back all the way to the third grade, I said I wanted to be the director of the Storm Prediction Center. And when I interviewed for my first job at the Storm Prediction Center, one of the questions that was asked of me was, the last question was, where do you see yourself in 10 years? So students, when you're going through jobs, that's a question that you should have an answer for, or some variation of it. Where do you see yourself in 10 years? And you really have to be able to read the interview as how to answer that, because some people may be threatened, some people may be looking for your passion and what you want to do. Me, I'm one of those people that I am looking for somebody who wants my job. And so when I was asked this question, I said, well, honestly, I said, I hope that I'm still at the Storm Prediction Center on my way to becoming the director of the Storm Prediction Center. I said this to the director. He still, to this day, gives me grief about that. It's one of those, he jokes that he won't take candy from me because he thinks it's poisoned. It's one of those, there have been times where I've been in his office when he wasn't, he'll walk in and I'll pretend to be measuring for drapes. And so we've had some fun with that. But for me, as someone, when I'm looking to hire, if you want to, this is one of these paradoxes. Everybody wants to be wanted and to be needed. Everybody wants to be the guy or the gal. And I'm no different. I'm one of these people that, playing sports growing up, I wanted to have the ball in my hands at the last second. I wanted to be the batter up with 2 outs in the bottom of the last inning. I always wanted to be that. And it's one of those, I'm always looking for what other people have been doing. And so that's kind of the person I'm looking for. And the paradox is you want to be the go-to guy, but if you're the go-to guy or gal, you're never going to get promoted because you're the go-to guy or gal. So you have to, as a manager, as a leader, you have to be cultivating someone to take your job. Otherwise, you become too valuable in your job and you can never get promoted to the next level. So that's one of those paradoxes that you have to be thinking about. And so I've always been ambitious towards this one goal. Arguably, in an org chart on paper, I'm like one step away from achieving my goal. Or so I thought, at least in terms of what my goal is. But we'll come back to that in a little bit. I nearly failed out of college. A couple stories about that. My first year in college, I was one of these students that never had to study. I never had homework. I remember an 8th grade civics test once where I finished the test before the teacher finished passing out the test. It just came naturally to me at that level. Then I get to college and wait, you don't have to go to class? What is this Super Smash Brothers? Wait, your key opens his room and they've got the game console in there and he's in class all afternoon? Needless to say, I didn't make very good choices my freshman year. And my GPA fell to the point where I was going to lose my scholarship. Had to take summer classes to get my scholarship, my GPA back up to keep my scholarship. And honestly, if it weren't for the grace extended me by my advisor and her husband, they both taught in the physics department at the University of Arkansas, I would have ultimately failed out because in University Physics 2, I more or less skipped the final to go on a storm chase. Drove all night, chased the storm, drove back, got back about an hour before the test, took a nap, went into the test, and bombed it. And needless to say, that was going to set my GPA to a point where I was not going to be able to do grade forgiveness and basically get it back up to where I needed to be. But for reasons that I do not know, and I will never really truly understand, the professor, the husband of my undergraduate advisor, did not give me the grade I deserved, but gave me an incomplete and let me teach myself from scratch everything that I did not learn during the semester and gave me a test at the end of the summer. And that became the grade that I got for that class. And it was, fortunately, I did well enough to get my GPA sufficiently high to keep my scholarship. Interestingly, fast forward, you would think I would have learned my lesson after doing that through the summer. Go to the fall, same professor, same gentleman. I had a take-home final, or excuse me, a take-home test. We were told that because of wintry weather, kind of like tonight, although this weather back in Arkansas, the state would have been shut down for weeks. Because of weather like this, he basically told his upperclassmen, take the exam, go home, work on it. It's due in my office by 5 o'clock tomorrow. I went home, or back to the dorm room. I worked on it all night, literally all night, and turned it in. And I turned it in on a Wednesday. We got it back on Thursday, and I had a 48 on a take-home physics exam, in which everybody else were in the 90s. It was open book, too. I got a 48. So I went to the professor on Friday afternoon. I still vividly remember it. And I basically told him, you know what? I'm dropping the class. I'm withdrawing from the university. I'm done. I don't want to get a stupid degree in math or physics. I've always wanted to be in meteorology. I'm transferring next year to a program that offers meteorology. And he looked at me and he said, just so you know, I respect the fact that you got a 48 on this test. I know that everybody else in your class went to the union and worked on it together, even though they weren't supposed to, and that you worked on it by yourself. I respect that. And he also told me, he said, you know, just so you know, an undergraduate degree in physics is not a degree in physics. What we're trying to teach you is not the concepts of physics, but how to think like a scientist, how to break things down into these complex problems into simpler problems to solve. And I don't know what it was, but from that moment on, things clicked. It's one of those, if you look at my undergraduate transcript, I've got C's and B's and an F in Calc 2. My freshman and sophomore years. But my junior and senior years, when I'm in the upper level advanced physics classes, quantum mechanics, all of that, special relativity courses, I'm getting A's in them. And it was something about the professor just taking that moment and speaking, not giving up on me. And it really clicked. So, yeah, I nearly failed out of being an undergrad. Nearly transferred. Regarding graduate school, my GPA after bombing my first 2 years was a 3.3, which was incredibly low to get into the University of Oklahoma School of Meteorology's graduate program. I initially got an acceptance letter, and frankly, I was surprised. 2 days later, I got a phone call saying that they had made a mistake, that I shouldn't have gotten an acceptance letter, that I was not getting an offer. My fiance at the time then accepted a fellowship at the University of Arkansas, their most prestigious fellowship that they offer to graduate students. And the decision was we were going to get married that summer, and we were just going to stay in Northwest Arkansas, and I would go on for a degree in a master's in physics and go be a high school physics teacher. The day before the unofficial graduate student acceptance day, which is like April 15th or something, I got a phone call saying, somebody turned down an offer, we have an extra spot, we're going to send you an offer, you're going to have to make a decision before you even get the offer, will you come? And I said no. My wife, my now wife, my fiance at the time, found out about it and she said, I'm going to OU, you can do what you want. So if it were not for her, I would not have gone to the University of Oklahoma. I would not have gone to graduate school and all the other stuff. I would not have happened the way it was. I would not be here. I'd be the high school physics teacher that's getting called to the superintendent's office somewhere in a high school in Northwest Arkansas, most likely, if it weren't for that. So I'm very thankful. I'm very, very blessed. I would love to tell you that I learned my lesson. Since then, straight in the arrow, grad school was great. Got more stories about that. We'll see if we have time for those. But one of the things that I really, 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 really like is probability and statistics. Unfortunately, I did not pay attention in those classes either as an undergrad. And so I wish that I had, because I wouldn't have had to spend all this time self-teaching. So we're going to do an icebreaker. What do you think the probability is of having at least 2 people in this room sharing the same birthday? Roughly how many people do you think we have in the room? On the order of 50? I would be willing to bet it's almost, I will take the yes, there are 2 people in here with the same birthday.
I will say yes.
Do we need to count it out? Do we know if anybody in here has the same birthday?
Yes.
I'm October 29th. Does anybody have an October 29th? David, is your wife the 29th? All right. So I heard some yeses. So who has the same birthday? I will march through and ask every single one of you. Because I have done this every time. In groups as small as like 20. And I have yet to be in a presentation where two people do not have the same birthday. All right, Victor.
June 10th.
There we go.
Cameraman, bam.
So most people think, oh, it's got to be really hard. There's 365 combinations and how this works. And you start doing the math. But it's actually, this is the curve. And it's when you get to about 22 and a half, so 23 people, you have a 50% chance of having at least 2 or more people with the same birthday in the room. By the time you get to about 50, it's almost 100%. So when you do statistics right, it's one of those, the world begins to open up to you. One of the things that you hear a lot about regarding flooding is if you ever, the 100-year flood. Does anybody know what the 100-year flood actually means? As Victor's laughing over here.
Isn't it the probability of like a flood happening within 100 years?
Yeah, so she said, is it the probability of a flood happening at least once within 100 years? Another way to say that is you have a 1% chance that a flood of that magnitude is going to occur on that day, or excuse me, during that year. All right, so it's a 1% chance. Let's say you're a homeowner and you live in a 100-year floodplain. Should you take out flood insurance? Yes. What is the probability of having a flood during the life of your mortgage? 30-year mortgage. 26%. You are 1 in 4 houses in a 100-year floodplain will experience at least one 100-year flood. The statistics and the model that you actually use behind this is the binomial theorem. The binomial distribution. So when you run the mathematics out, it's actually like 26%. How about a 500-year flood? What is the likelihood of experiencing a 500-year flood during the course of a 30-year mortgage? It's actually around 3%. If you start going down to a 1,000-year flood, it's still really high compared to what you would think. And it has to do with the fact that how we calculate probabilities. We don't do a very good job explaining probabilities and statistics in our education system because it's hard. And we don't understand it. If I told you you had a 1 in 4 chance that your house is going to flood during the life of your mortgage, are you going to take out flood insurance? Would you rather hear that, or would you rather hear, oh yeah, you're in a 100-year floodplain? So how we communicate this kind of information is one of the things that I've always been fascinated with. And it really comes to bear at the Storm Prediction Center. Storm Prediction Center, we issue severe thunderstorms, forecasts, probabilistically for tornadoes, severe thunderstorm winds, hail. As a little sidebar, this is one of my favorite cartoons. It's a picture of God laughing at the TV, and the angels are saying he's watching his favorite comedy. It's a picture of a 5-day forecast. But what I want to posit to you is all forecasts are wrong, but some are useful. And inherently what I mean by that is, you look at a Storm Prediction Center forecast, we are not going to be perfect with all of our forecasts. There are going to be areas in which we are wrong. And being an operational forecaster and working the desk, that is, you are beat over the head with that by every day. You have to real quickly learn that you're not going to be perfect. That's part of why I have no shame whatsoever standing up here in front of you telling you that I almost failed out of college. multiple times. In fact, even working at the Storm Prediction Center, I did things that I'm surprised I didn't get fired over my first couple years. Nobody's perfect. But I'd argue that people are useful. Same thing with our forecasts. All forecasts are wrong, but some are useful. All right, another pop quiz. If the meteorologist on television says there's a 50% chance of rain tomorrow, is he or she just guessing? Be honest with yourself. If they say 50% chance, do you think it's just a guess?
Yes.
I hear some yeses. I hear some people say no. Why do people think that it's a guess?
Does 50% sounds like there's even chance for rain or no rain?
Yeah. I got a quarter. What's the probability of heads? What's the probability of tails? Yeah. So we think, oh, a meteorologist gives a forecast of 50%, and they're just flipping a coin. They're literally just guessing. But they're not just guessing. Here's another way. What's the climatology of heads? It's 50%. What's the climatology of tails? 50%. What's the climatology of rain tomorrow? Generally speaking, it's actually around 10%. If you don't know what something is and you're going to guess, you don't guess based on a coin flip. You guess based on climatology. Climatology is the useless forecast. Climatology is the forecast where you have no additional information is what you go with. We've equated it with 50% because we all fall back to this, the flipping of a coin. But the climatology of coin flips is 50% head, 50% tails. With that in mind, if I say there's a 50% chance of rain tomorrow, is that useful? What if I rephrased it and said, there's a 5 times greater chance of rain tomorrow than normal? Is that useful? They're equivalent in terms of the probability and the statistics. It's all in how we frame the information. Meteorology is at the intersection of math and physics, which is why I actually went and got a degree in math and physics. I've always wanted to be a meteorologist. I could not afford to go to an out-of-state school. The University of Arkansas essentially offered me what amounted for all practical purposes as a full ride if I stayed in state, but Arkansas didn't have a meteorology program. And so I went and I looked at all the faculty members at some of the big name universities. And one of the recurring themes that I saw is most of the faculty members at some level, either as an undergraduate or in graduate school, had a degree in either math or physics. And so meteorologists lie somewhere between the chemists and the physicists. We have atmospheric chemistry, we have basically all what we're doing is applied physics in the atmosphere, and mathematics is the underpinning of all of this. My wife is a mathematician, so she likes to rub this in on my face. This is our mission statement at the Storm Prediction Center. This is roughly, we have 22 federal forecasters. We have 11 federal management and support. I'm part of the management, and I oversee the support group. We have 12 contractors or Cooperative Institute employees. We're 24/7. We're located on the University of Oklahoma campus. This is actually our building in the background that I'm using as a slide background. We're co-located with the National Sphere Storms Laboratory. And this is essentially what we do in a nutshell. Everything that we do at the Storm Prediction Center stems from probabilities. The underpinnings of all of our forecasts are probabilistic, which is why I started the talk focusing so much on probabilities. All of those categories, slight, moderate, high risk, enhanced, marginal, all of those are actually derived out of the underlying probabilities of tornadoes, wind, and hail. We use the probabilities to drive our communication. That's why you don't see us giving a press conference when Washington, D.C. is under a severe risk. unless it's the same kind of severe risk that would prompt a press conference for elsewhere, saying that basically the threat for DC is high enough. We'd also do a press conference if it were, say, Wichita, Kansas, given the equivalent risk. Our press conferences and our communication strategy is fundamentally tied to the underlying probabilities. And we actually are starting to build layers off these probabilities. And if we have time, I'll show you in the other talk what we're doing with these probabilistic forecasts. And so this fundamental nature and why we focus so much on probabilities at the Storm Prediction Center, and I would argue all of meteorology should be probabilistic. You should never see a deterministic meteorological forecast. That's not to say that deterministic forecasts are wrong or should not be communicated, but you should, if you're going to stay true to the meteorology, your information is going to be probabilistic in nature. How we communicate that to external users becomes a societal piece, and that's where the determinism comes in. But those should not, and those can may necessarily deviate from the underlying meteorological probabilistic information. But that's where things like social scientists, communication experts, are going to have to help us on how we frame our messaging and work with us to come up with things such as, is 50% chance of rain more useful, or is 5 times more likely than normal the proper way of framing one's risk? So this is where working with communication specialists are going to help us. I like to show this slide primarily for what you see at the bottom middle, the double pendulums. How many people have taken calculus? How many people have gone on and taken something like differential equations? How many people have taken more than one course in differential equations? In differential equations, there's 2 fundamental kinds of equations. You have the initial value problem, and you have a boundary value problem. In a very high-level nutshell, an initial value problem is you need to know the state of everything at time t equals 0 to be able to integrate forward in time and say something about the end state. In a boundary value problem, you need to know everything about the boundary and what is passing through that boundary, and you can then say something about the state of things in the future. How that relates to the meteorology. Is meteorology an initial value problem or a boundary value problem?
Both.
Meteorology is not both, but I'm going to get there in just a second. It's an initial value problem. If we knew where everything was at t equals 0, and we had infinite computing power, we could solve and give a perfect forecast using the governing equations of motion going forward. But we don't know where every molecule is at t equals 0. This is the idea behind ensembles. We perturb the initial state, plug it into a model, run different simulations, and then try to probabilistically assess what the potential range of solutions are. And the double pendulum here is to highlight that. When we begin at t equals 0, visually, when you look at it, it looks like they are starting from the exact same point. But one is ever so slightly nudged differently than the other. And as you kick the pendulum off, you see, first it starts off, it looks like they're in the same, there's slight differences, but real quickly the differences grow upscale and become highly chaotic, and you can't necessarily distinguish that they came from almost identical starting points. This is the fundamental premise of chaos theory, which was discovered by a meteorologist at MIT. And basically, if you've ever heard of the butterfly effect, it's not that a butterfly flaps its wings in Argentina and a tornado hits Moore, Oklahoma. It actually has to do with what's known as attractor basins. And when you start to deal with some of this probabilistically, you end up with these different solutions that rotate around in highly predictable space until they get close enough to the edge, and then they may switch off to another basin. And when you looked at this, you end up, the picture of this looks like a butterfly. And so this is what is known as the butterfly effect. But it means that the atmosphere is, meteorology, weather, is an initial value problem. Now, to tie this back into when I said there are two kinds of boundary value problems, I'm not going to get into a discussion about climate change. But I do want to dispel one notion. If somebody tells you, why should I ever believe a climate prediction when you can't tell me what it's going to be in 10 days? The reason why scientists believe that you can say something about climate and not necessarily about weather at 10 days is because weather is an initial value problem. We are trying to predict the exact end state. Climate is a boundary value problem. We don't care about what everything is doing inside our domain. We are trying to assess what is happening overall to the domain. And the boundary is the forcing from the sun and greenhouse gases. And so in a climate model, you're not going to be able to say on January 2030 or 2050, January 15th, there's going to be a tornado outbreak in northern Illinois because of climate change. You're never going to be able to say something that specific. But what you can do is start to aggregate out bulk statistics and say something about the likelihood or the chance of a tornado outbreak in northern Illinois in January may go up in 2040, 2050, 2060. And it has to do with the fact that climate is a boundary value problem, not an initial value problem. All right, science lecture over. So real quickly, this is basically how probabilities work at the Storm Prediction Center. Everybody wants to know, is there going to be a tornado today? Yes or no? I can't say that, sorry. We got, the world's not black and white. We got to embrace the grayness. So how likely will there be a tornado within 25 miles of a point where I am today? Well, right now it's probably really low. But how about April 24th? Say in central Oklahoma. It's about 1%. It's toward the climatological peak of anywhere in the United States at any time during the year. So there's no point in me telling you that between 0 and 100 because we're dealing with such rare forecasts. Storm Prediction Center broke our probabilities down into these bins for tornadoes that you see right here: 0, 2, 5, 10, 15, 30, 45, and 60. And then we mapped those probabilities into categories to communicate risk to those who do not wish to deal with probabilities. Marginal, slight, enhanced, moderate, high. So I'm going to go back to this and say, if I told you that climatologically speaking, you have a 1% chance of a tornado today, and the Storm Prediction Center comes out and says, we've got a 15% risk of tornadoes forecast today. 15% seems really, really small. If I told you that you had a 15% chance of catching the flu in the next 2 weeks, would you stay home and never go anywhere? Thanks, Victor. 15% is relatively low risk. Most people won't do something if the chances of winning the lottery is 15%. It's actually kind of high. I probably would play the lottery at that point, but that's a moderate risk. What if I told you there was you're 15 times more likely to see a tornado today than normal? It's the same exact information, it's just how you frame it. Now, central Oklahoma in April is a little bit different. But how about, let's say, northern Illinois on January 7th, 2008? And we put you in a 15% risk. Or how about, was it April of 2016, 15, 14 was... When your underlying climatological risk of something happening at that point, we're talking like 0.02%. To make the math easier, I'm going to say 0.01%. And then we put out a 10%. I'm saying that you are 1,000 times more likely to see a tornado today than normal. Does that get your attention? It's, again, the same exact meteorological information. We just don't know the best way of communicating. And what works, what some of the research that I've seen is what works for us here in the United States doesn't work in other countries. How many people know they're right in their left hand? Right from their left hand. How many people know the difference between east and west? If I were to just drop you somewhere randomly and say east and west, could you figure it out? Most of us probably could. It'll take us a little bit. But some of the social science research has shown is it's all about your reference from growing up. There are cultures that do not teach you left hand and right hand. They teach you east and west. And so if you ask them left and right, they look at you like, what? They're used to identifying everything as the eastern hand and the western hand. So how we communicate really goes all the way back to how we learn in elementary school. So this is something that we're going to be wrestling with until we start to tackle it in elementary school and make it more of a concern. And part of where this comes from is the Weather Service is embarking on something called facets, forecasting a continuum of environmental threats. And if I had to boil facets down into two tenets, I would say tenet one, the probability that meteorological information is inherently probabilistic, and that's what we should be producing. Deterministic information is inherently societal and should be geared towards making and helping a society understand it. So along those lines, you could imagine that 2040, 2050, the Storm Prediction Center is issuing these probabilistic forecasts that are updating every hour. And you could have in central Oklahoma probability that says over the next 3 to 6 hours that a tornado probability is like 10%, and we may not issue a watch. Whereas if it's 2% in upstate New York, we may. And the reason for that is we're going to try to be true to the probabilistic meteorological threat, but how we then communicate it to the public, the local public, is going to be a societal problem. And the idea is what's best for society at that location. Just to be clear, I'm not saying that this is what is going to happen. I'm saying the idea is this is what we're wrestling with as an agency as we move forward. So this ends one train of thoughts. I can go back to sharing embarrassing stories about myself, or I can show you how to infer tornado intensity from the Storm Prediction Center forecast. Infer tornado intensity? Okay. We're not going to necessarily go through all of this, but part of what we're doing is if you have probabilistic information as the underpinnings, you can actually do things and derive things out of the probabilities such that businesses and private sector can work with large-scale corporations to identify what their risk threshold and risk tolerance is, and you can build these cost-loss models so that you can tell people if the probability of rain tomorrow was 10%, go ahead and lay the concrete. But if it's 20%, don't lay the concrete. And you're going to maximize profit and minimize loss in aggregate by doing this. So the Storm Prediction Center wants to actually get towards our probabilities being as accurate as possible so that private industry can start to do that. So the Storm Prediction Center is trying to develop the capability to estimate probabilistically a range of societal impacts based entirely on the forecast. Now, if you want to know what your risk is of a tornado at any one location, you would use the exact forecast from the Storm Prediction Center. But if you wanted to know what your aggregate risk or exposure was for a day, I've developed a technique that allows you to basically do some statistical resampling to actually back out some of this probabilistic information, these potential impact information. But in order to do the resampling in this, you've got to have really accurate probabilistic information, which we've been working on. But the other component about impacts is, regarding tornadoes, which would you rather have? Your house be hit every day for an entire year by an EF0, or your house be hit once by an EF5. And I say that to get at the fact that impacts are entirely driven by intensity. For an impacts, effectively, an EF0 may be a nuisance. You may lose power, a few shingles. It's not really going to have much of an impact. An EF5 can completely alter the destiny of a community. Does anybody know what the major powerhouse city was in the late 1800s in the Midwest? It was St. Louis. What happened in 1896? Massive tornado went right through downtown, destroying it. Guess what happened? They lost commerce, and to compensate for it, companies started using shipping. What became the big shipping hub after that in the Midwest? Chicago. Chicago grew at the expense of St. Louis because of the massive infrastructure loss from a massive tornado in the late 1890s. So if you really want to get at impacts, you really got to get at the intensity. And so it turns out, and this is kind of some subtle nuances here. Let's take a look at the thing on the left, in the yellow box. So if you take a day in which the Storm Prediction Center has no probabilities forecast for tornadoes at the initial outlook for the day, the 12Z outlook, we have no probabilities. That does not necessarily mean that we're not forecasting tornadoes. We're saying that the probability of a tornado is less than 2%. Sometimes tornadoes do happen, especially in California with some of the cold core lows as they come ashore. The resulting distribution and counts of the tornadoes in this forecast setup, where we're forecasting less than 2%, is on the left. 80% effectively are EF0, almost 20% are EF1, 2% managed to achieve EF2, and there was 1 EF3. Now, again, this does not necessarily mean that the resulting Storm Prediction Center forecast or the last forecast before the tornado occurred was still 10%, or excuse me, still less than 2%. This was, the initial forecast was 2%. The forecast may have evolved in time. Then you can look at days in which we don't have what's known as a hatched area. The hatched area is basically, it's a black hatching that we put on top of the forecast to indicate the potential for significant tornadoes. Tornadoes that achieve EF2 or stronger intensity. So on days in which we do not have a hatched area, and we're in the summer months, May through October, we're in the warm season. Flow tends to be a little bit weaker throughout the troposphere. On those days, the resulting distribution shifts a little bit more towards stronger tornadoes, but not all that much. You're still primarily favoring the weaker tornadoes. If we look at distributions in which the Storm Prediction Center has a hatched area, or we're in the cool season, where the flow in the troposphere is much stronger. So we're either in November through April, or we're in the warm season and we're forecasting a hatched area. The resulting distribution shifts even more towards the stronger tornadoes. And the reason we break it down into cool season versus warm season is our current forecast right now, in order for us to draw a hatched area, we have to have at least a 10% contour for the coverage probability. So if we're not forecasting at least a 10% chance of tornadoes, we cannot draw a hatched area the way we've currently defined it. Well, in the cool season, we tend to have situations where we're not going to have a 10% chance of tornadoes. But because of the strong flow, if a tornado does occur, we know that the strong flow is going to allow the tornado to be a little bit stronger than it would have been otherwise. So you tend to see EF2 tornadoes in the cool season in the southeast. But instead of having a lot of tornadoes, you may have just one or two of them. So we can't put a hatched area the way we currently define our forecast in the cool season. So we're basically saying cool season tornadoes favor slightly stronger than warm season non-hatched tornadoes. Now, if you take the hatched area inside a storm prediction center high risk, so a tornado probability of 30% or greater, so the black, essentially the magenta and purple area in this. If you look at just the tornadoes inside a hatched area with a tornado probability of 30% or greater, this is the resulting distribution. And you see that no longer is the mode EF0, it's actually shifted to an EF1. And you actually see that EF3s, EF4s, and EF5s are also considerably higher, the probabilities, relatively to other ones. The probability of a significant tornado, EF1 or stronger, or excuse me, EF2 or stronger, on the far left, so in this scenario, is less than 1%. A significant tornado on this one, no, I'm sorry, it's about 2%. On this one, I believe it is about 4%. It's about 8%. It's about 16%. Another way to put it is you are exponentially more likely to have a significant tornado as SPC ramps up the coverage probabilities. And we have our hatched area stuff. So we've actually been forecasting and communicating intensity information hidden in our forecast for quite a while. Our forecasters did not believe when we told them that they could predict intensity information with their forecast. There's no way you can predict tornado intensity information. But statistics don't lie. Actually, if you believe Mark Twain, they do lie. But the data don't lie. And when you start diving into it, it's actually in there. And so we're actually in a culture shift right now at the Storm Prediction Center. We're trying to communicate to our forecasters, you can do this. How do we do it explicitly now? Because for us to model potential impacts from a forecast, we need to know the coverage and the intensity. And so in the hazardous weather test bed spring forecast experiment, one of the big things that we have in our building, last year for the first time we began to explicitly ask our visiting forecasters to attempt to draw not just the coverage, but also potential areas of where the intensity would be. And you may be thinking, how is that useful? Well, if you divorce intensity from just the coverage, a perfect example of this is dryline convection in the plains, where you don't know if you're going to initiate. But if you look at some of the research work done by the Doppler on wheels, Curtis Alexander and those guys, if you look at a climatology of supercellular tornadoes, the median tornado intensity is EF2. In other words, I already know that if I've got storms developing on the dry line and I strongly believe that they are going to be supercellular in nature, that I'm essentially starting with a SIG-TOR as my default answer. I can't communicate that in the Storm Prediction Center current operational forecast suite, because the coverage may be less than 10% because you're only going to get 2, maybe 3 storms up and down the dry line. But I can already tell you, just conversationally, yeah, there's only going to be 2 or 3 storms, but if they do, you'll probably get a nice tornado out of it. Right now I have no operational way of communicating that to you. So we're working on how to actually build the capabilities and the capacity to explicitly communicate that information to all of our partners. So I can keep going. I can share more embarrassing stories. I can start to tell you the end of why Python ruined my life, or I can end right here. It's up to you. 5 more minutes. Okay. I'll use this to explain some of the stuff that I alluded to earlier at the beginning. I think by now I've made it abundantly clear that my dream job was to be the director of the Storm Prediction Center. My first year or two at the Storm Prediction Center, I was really active on social media, had amassed a huge Twitter following. I didn't really appreciate what that meant. I retweeted something that one of our forecasters, who was also the union steward at the time, said. He basically was complaining about SBC management and the fact that our data flow was being flaky at the time, and even though people were working on it, they were frustrated that it wasn't being fixed fast enough. And so he basically said it's absolutely embarrassing that SBC forecasters are having to use radar scope on their phones to monitor ongoing severe storms, which was a huge exaggeration. But I was trying to curry favor with the union steward at the time, so I retweeted it. Problem is, our reach was considerably different. By 11 o'clock that evening, and I tweeted it about like 9 o'clock that evening, by 11 o'clock that evening, the director of the Weather Service, from my understanding, the director of the Weather Service had already been contacted by 2 separate senior vice presidents at AccuWeather. Is this true? This is an outrage. Needless to say, that by the next morning, the Storm Prediction Center was given an ultimatum: fix this by the end of the week or else. I just hit retweet. I didn't even provide comment. I just hit that retweet button. Well, my reach was a little bit greater. But what I didn't appreciate when I hit that retweet button and all the fallout was the amount of work that I put on my coworkers, who had to essentially develop and implement a solution in 3 days. And I had no idea the amount of frustration and agony that I caused them, until one of them blew up at me. To this day, he's one of the nicest guys. In fact, he's actually one of the people that encouraged me to apply for my current position, which is now ironically his boss. He lit into me. I have never heard him yell since or before, but I got a butt chewing. I thought for sure I was going to get fired. I was still on probation. It would be easy for them to just fire me. And the director was like, I don't care what happened. It's not relevant. Learn your lesson, move on. Had another event a year later that actually caused some big controversy with AccuWeather. And again, the director at the time, he's still the current director. Did you learn your lesson? Okay. He kind of shielded me from a lot of the fallout, took it on himself, moved on. So in that regards, I really appreciate and I really learned the value of having bosses that shield you and take the arrows for you. So you would have thought that I would have learned the lesson. And the second one, I've curtailed. For the most part, I've stayed away from social media snafus. In fact, I got rid of Facebook during the 2016 or shortly after the 2016 election because I was afraid I wasn't going to be able to keep my opinions to myself. It's actually the best decision I've ever made. Just throwing that out there. 2016, I became the WCM. I finally got out of being a techniques development meteorologist. As a techniques development meteorologist, have you seen the Storm Prediction Center graphics that are like CWA or state or FEMA region, the prettier looking that you tend to see them on social media? I created all of that from scratch. That's essentially kind of what I was doing as a TDM, developing stuff like that and doing some of the statistical work. I was having fun, but I was like, you know what? I get to the next level, get out of being a bargaining unit employee, life would be so much better. Got out of being a bargaining unit employee, became the warning coordination meteorologist. Still got to dabble a little bit with the programming, but I can still remember the day that my boss basically said, your days of programming are over. I didn't really believe him at the time. And he wasn't being 100%, you're never going to program again. But basically he was saying is you're not going to be able to embark and take on these huge, big projects like you were as a techniques development meteorologist. I didn't listen to him. It's a reoccurring theme with me. I undertook a couple. I tried. If anybody follows me on on Twitter or anything like that, you've probably heard me reference Mappy, which is a Python package to make maps that I've been promising since like 2014, 2015, and I still haven't delivered it yet. I did get Sharpie up and going. Didn't finish it. Somebody else had to come finish it for me. But my programming was significantly limited. But I was still getting frustrated. I felt I was being cut out of things. I didn't understand why we were doing things the way they were. If I get to being the branch chief, everything will just be better. Got to be branch chief starting July 21st. Until this week, in which I had to run a couple scripts for creating some graphics for the fires that are going on in California, I have not touched programming since July 21st. I'm now in Excel spreadsheets. After I swore off as a graduate student, I learned all this programming so I would never have to touch an Excel spreadsheet again in my life. Now all I do is Excel spreadsheets, it seems like. And I share all this again, and as I said at the beginning, I love my job. I love who I work with. I love the fact that I get to go back to Oklahoma and work forecast shifts with some of the smartest, funniest, greatest people I've ever known. And until you work in one of those environments where you know that you've got these guys that are working with you and we're all in it together, and you could have a bad day and you're going to be off your game, but you know that your guys are going to have your back. And at the end of the day, we're actually doing something. Until you work in that environment, I really can't explain what it is. If I become the director of the Weather Service, not that I want that job, if I ever became something like that, I could not still work shifts, it'd be like the worst thing you could possibly do to me. And again, I say all that. I thought in third grade I wanted to be the director of the Storm Prediction Center. I wanted to be the person with the ball in my hands. I wanted to be the person that was making the decision. Yes or no on a tornado watch. Are we going to go high risk? What I thought that I wanted was a director. Turns out, what I really wanted was to be a lead forecaster, to work in that team environment, to be making the forecasts. I thought the director was the one who ultimately got that say. Do you know what the director spends most of his time doing? Making sure that we have enough funding to pay everybody that we have working with us. Making sure that we're responding to requests from Congress, from OPM, from higher up the executive branch. Making sure that people's leave is approved and shifts are covered. Going through all sorts of these trainings, appropriation law, all of that. That's now what my life has become. I get 300 to 500 emails a day. I don't do a very good job keeping up with it, but I'm trying, I'm learning. I'm doing better than I was, say, 3 months ago. As I got closer to my dream job, I realized it was a nightmare. Best job that I could possibly have had at the Storm Prediction Center is my first one. If I could go back and tell myself in 2013, don't leave this job, I would. And again, it's not because I don't like what I do, but core to me, what makes me happy deep down is what I was doing. I just would not let myself be happy when I was in that job. Kept thinking I had to get to the next rung. I had to rise the ladder. And now I'm in a position where, don't get me wrong, I will have the opportunity to shape and move SPC in directions I could only have dreamed of as a techniques development meteorologist. But the difference is I'm going to be setting policy. I'm going to be fighting bureaucratic politic nightmare stuff. I'm not going to actually be getting to do the programming in the day-to-day. I have a choice. I can begrudgingly accept that role and then take it out on my team, or I can embrace that role and try to protect my team. And for me, I've made the choice that I'm going to embrace that role and I'm going to protect my team as much as I possibly can and push back on all the stuff that's coming to them. I'm trying to empower them. The idea is, I'm trying to instill a culture of success lies with you, failure lies with me. And that's because if you fail, that means I didn't provide you something. I didn't get you the support you needed. I'm trying to instill a sense of common purpose, common vision. This is where we're going. Push down the decisions to them so that they can focus on it. And I can turn all my attention to making sure the bureaucratic avalanche of paperwork that comes to us every day never actually reaches down to their level. And by doing that, I hope to empower these guys to be able to answer and do some of the things that we can do. How are we going to do this conditional intensity, this separate intensity and forecasts, as well as the coverage forecast? How are we going to do continuous probabilities? Because right now, is the risk right here the same as the risk right here? If you look at just visually, it makes common sense to us. No, it's not. One's closer to the 45, one's closer to the 30. But if you take our underlying forecast, this is the exact same risk that we're communicating. So we've actually got automated code behind the scenes that actually turns those into continuous probabilities. And we'll hopefully be releasing some of that soon. This is stuff that those guys are going to get to do. I would love to do it. It's the hardest thing for me not to do that. First meeting I had with my new guys, as I told them, I said, I make a promise to you, I'm done programming. This first year is going to be a transition as I transition what I've been doing over to you guys, but I'm done programming. I got your back. You guys get to do the fun stuff. It's going to be hard. If you see me run afoul, you have my permission to say, hey, back out of it. We got this. But these are the choices as you move up in a scientific organization, as you move up the leadership ranks. You no longer are doing the science, but you are guiding and directing and protecting the science. And ironically, and I'll end on this, part of the PhD process is you have to go through a general exam before you even get to the qualifying, before you even get to the writing a dissertation and defending it. In my general exam, the last question asked of me was one that no one else in the room told me. They told me after the fact they had never heard that asked in a general exam. And the question was asked by my advisor, and he said, there are two kinds of PhDs in this world. Those who ask for money and those who give money. Which one are you? My heart wants to be someone who asks for money, because that means you get to do the research. You're doing it. But my skill set has evolved, and I have been put on a path. So all those stories where people were looking out for me, I would not be where I was if it weren't for those people. So I feel like I have been put on a path and being trained actually to be the one to give out money, not to ask for it. And so I said, to the surprise of everyone in the room, I'll give out money. I'm an administrator. I'm a bureaucrat. But we need good bureaucrats. At least I want to keep telling myself that. So Python ruined my life. If I had not been a good programmer, I wouldn't be standing here as the branch chief, working in Excel spreadsheets, doing budgets, responding to emails, grading contracts. But the good news is I'm now in a position for if you go on and you graduate and you want to come work at the Storm Prediction Center, I'm now in a position to help you get there. So use me as a resource as you go through your career. So thanks.
Okay, thank you, Patrick. Do we have time for a few questions? Do anybody have some questions here they'd like to ask? $42.
Just going back to your thought about tornado intensity on dry lines being EF2, and you not, or maybe I misunderstood, or portraying a way to explain that fully. Couldn't you to just take that from a background state of the synoptic pattern, given dry lines, given lee side lows, given strong cap is going to lead to lesser storms and strong low level jets. So couldn't you kind of ensue, at least in my thought process, that given larger SRH and all that background stuff, the synoptic and mesoscale, that you're going to probably be at least on that EF2, if not more, scale?
Right. So the issue is our current operational product suite doesn't allow us to communicate that, because we have to have enough storms to warrant a 10% coverage area. And so if we can't draw a 10% coverage, we're not allowed to then put a significant hatched area on. So we know meteorologically, for all the reasons you just said, SIG tours are likely today. We just do not have an official product stream that allows us to put that in there. Now, we may put that in the text, but one of the things that we've learned is nobody reads the text. Believe it or not, that's actually why we now have marginal risk. The marginal risks have been there all along in our outlooks. They were called see text. But nobody would read the text. So now by putting the marginal risk on there, which it's the same exact probabilities under the hood, people now are paying attention and know that there's something there. So we've handicapped ourselves in the past by limiting how we defined our initial probabilities. So we're having to undo that damage at present for all the reasons that you mentioned.
Other questions? Rhiannon?
I can ask you guys more questions.
I have a question for you.
Oh boy.
No, it'll be nice. As we continue down a path towards automated vehicles and forecasting, right, starts to take that approach, what do you see the role of a storm prediction center forecaster in 10 to 15 years? Are they...
Can we cut the tape?
Well, do you see those folks doing exactly what they're doing today?
No.
Are they decision support folks? What do you see the role of a meteorologist at the SPC maybe once you're director in X years?
All right, so I'm going to take that and answer it in two parts. First, Weather Service as a whole. The Weather Service as a whole is kind of evolving to this Impact-Based Decision Support Services, IDSS. And so what you're seeing is field offices are becoming more and more the outreach vehicles to providing and communicating our weather forecasts to decision makers, emergency managers, fire chiefs. I can tell you right now, the Weather Service office in Southern California in Oxnard, the Los Angeles area, they're having numerous phone calls with the fire chiefs about the ongoing fire situation. I'm on some of the email threads, and it's extensive. They have daily calls with dozens of the fire chiefs in the area. That's going to become, with time, I suspect, me speaking, that is going to become more and more of an increasing demand placed on the local forecast offices. So you're going to see the local forecast offices increasingly do more and more of the DSS part. So communication skills are going to become really, really important. The ability to make a nice graphic to summarize all of this information is going to be really important. At the national centers, that's probably going to be where you're going to see most of the science and meteorology being done for the longest time. And it's because we've got these core competencies across the centers, and we are doing a lot of it. Now, to tie this specifically to the Storm Prediction Center, we are actually both very lucky and in a really bad position in the grand scheme of things because numerical weather prediction models do not explicitly predict our phenomenon. Almost all or all of the other phenomenons predicted by the Weather Service are explicitly produced by the models. Hurricanes, flooding, or I shouldn't say flooding, but the heavy rain. Flooding is actually an impact, not a meteorological phenomenon. But so heavy rain, winter storms, coastal erosion type stuff where you have the winter storms and the wind. All of the other, those hazards are explicitly, you can get them from a model, which means you can then start doing calibration and developing guidance on it. We're going to be a long time off before we start having operational models that are going to be predicting hail, tornadoes. You could argue that we're not that far off from being able to predict strong winds, strong thunderstorm winds from the models, but hail and wind, we're still a long ways off. So that means, at least for our forecasters, they're going to still be in the forecasting part. And what I am preaching to our forecasters is, just because that you're still going to be forecasting doesn't mean that the models aren't going to be getting better. There are going to be people that are going to be trying to take these models and develop tools and derived meteorological covariates and combining them to come up with ways and calibrated guidance to say the probability of a tornado is X, probability of hail is Y, derived from these high resolution models. What I'm trying to convince our forecasters, and what I believe will be the role of the human, at least at the Storm Prediction Center for the next decade or more, is all that expertise that you build up by looking at the weather day after day after day. So, as an aside here, the Storm Prediction Center are experts in severe thunderstorms and tornadoes, not because we're the smartest people in the room. We're experts because we're smart enough, there's some baseline, but we do it every day. Very rarely will something happen across the United States that we have not seen before and have some idea of the potential evolution and impacts of it. Now, when you think about a local forecast office and the way rotating shifts work, you may have 1 or 2 chances a year to test your severe weather experience, whereas at the SPC, you're doing it 1, 2, 3, 4 different regimes per day. So our expertise comes from the fact that we do this all the time. So what I'm trying to get our forecasters to do is take that expertise, and we've got to then convert that expertise to build the next generation guidance in-house. And basically have this feedback process where we build the guidance, which then informs the forecasters, allow them to build better understanding and models of the atmosphere, or theoretical models of the atmosphere, which then inform the next generation of knowledge that can then be pumped back in and develop this feedback cycle. If we don't do that, this is where I start to get in trouble. If we don't do that, there is going to come a point where the United States is going to have to make a decision. Are we going to continue to invest all this money into government services as we continue to rack up deficits? And I'm not getting into the politics aspect of it, but there will be a decision where politicians have to assess how much money they're going to put into the Weather Service. It is much cheaper to run a numerical model and have somebody develop an algorithm to run off that model than it is to pay for 3,000 human beings to produce weather forecasts. At some point, somebody is going to say, the model's good enough. And so what I'm trying to instill in meteorologists, yourself included, the worst thing you can possibly do for your future career is to say, Model A said this, Model B said that, we took the consensus. I don't need you to do that. I can write an algorithm real quickly, one time, to say A plus B divided by 2 and produce the forecast. You've got to demonstrate how you are using the guidance that is given to you and applying your expert human knowledge to value add to what the model is doing. And so the idea is the human has got to continue to show that they can add value to the models, or eventually they're going to be replaced by it. Admittedly, at the Storm Prediction Center, I think we have an easier job adding value because it's such a harder problem because the models don't explicitly predict what we're doing. But that is the fundamental challenge, that if you want to do explicit forecasting, that is your challenge. Add value to the models. Otherwise, you may be a government meteorologist, but you may be spending all your time giving briefings and being more of a communicator rather than actually doing forecasting. Does that answer your question? Sorry to be such a downer.
Hi there, Patrick. And just first a comment to piggyback off what he said, since we have such a young crowd. And so you may have scared him, the idea of a briefer and not a scientist. Coming from the WFO and the IDSS era that Patrick talks about, it's here already in Chicago. And it's a lot of support pillars that we're providing constantly. And SPC is critical for our science foundation when the weather gets real active, because the mesoanalysis can get challenging to support that service. So we really like seeing the fundamental science here that you showed, Patrick, and how you're conveying it to us, because the WFOs are really one of their biggest users. And while we try to do the science to service on the local level, they help that support. Are you worried at all with the evolution that SPC there will get tested to be able to keep the science as strong as it is. Whenever I visit, the phones don't ring very often. If they are, they're WFOs, and that's great. At my office, they're ringing regularly when the weather's active. And so
I almost called you guys and just dropped in this afternoon.
that would have been great. We may have put you to work, including programming. But are you worried at all as the future evolves and the service pillars, even at the national level, FEMA and others who may, in this national briefings, in the WCM role you had for a few years, I know you saw that, the social media era and that. I think it used to be that SPC's biggest users were us and maybe national entities and national media, but it's your forecasts are out there everywhere. You drive the message. Are you worried keeping your forecasters sharp on the science and having the time for the science? You've got a lot of new tools coming along that the HWT is working on. Are you have any concerns going forward?
I always have concerns. They pay me to stay up at night thinking about them. We do have a challenge, but we've got a lot of motivated people at the Storm Prediction Center. The biggest challenge that we have right now is complacency. It's easy to fall into the trap of believing the hype that is said about you. After a big severe weather event, it's easy to think that you're really good. If you've had a really active severe weather season, you could be really good. It's easy to start to fall into that trap, and then you don't push yourself. And when you do that, that's when you get overtaken by some of the innovation. So as a manager, I wrestle with how to do that. But then the flip side is, then you've got some people who are so motivated, they want to do so much that they run so far out, and it's like you're trying to turn the ship to the right, and they're like it's like you're playing chess and they're playing checkers, or it's like how to keep everybody rowing in the same direction. Real quick, I do want to say is, as a warning coordination meteorologist, I realized when I said that you could just be a briefer, that may have been negative. I essentially was that person. It's an incredibly fun job. But a lot of people don't want to do that. So if you don't want to do that, you want to be a forecaster, focus on the value add. If you like interacting with people and being in some high stress, high environments where a lot of people are counting on you, weather service briefing, on-site support, DSS, it's fantastic. It'll really test your mettle. I do want to clarify, I'm not trying to disparage one or the other. I really actually enjoy the DSS, and most of my stuff is actually on the DSS side. One of the things that we're going to see, that I think actually that the SPC is going to see, is, at least in the field offices right now, there are a lot of people who join the Weather Service for forecasting, not for DSS. The younger crowd, the younger generation tends to be more involved in the social media and the DSS stuff. The older generation, the seasoned veterans, some have bought in, some just say, leave me alone, I want to do the grids, I want to do the forecasting, I want to be down in that. As more and more of this automation and high resolution guidance comes on board, the national blend of models, the stuff like that, my fear is forecasters and the local offices are going to feel more pushed out from doing the meteorology than they really should. Again, it's value added. I really think that at some level we should still, even in the field, be doing meteorology. But the demands are astronomical of being placed on the field offices right now. But those holdouts I see as severe is going to be one of the last things that becomes automated. And so I think that you're going to see a transition to more and more people in the field wanting to do and have a say in the severe program for the Weather Service. And that means more collaboration with SPC. But we have some of our older forecasters as well, and the history of SPC was we were internal Weather Service guidance. Our products actually said for internal government use only. They're not used to collaborating and talking to the field. And so how we bridge this, having SPC work closely with the field, as the field is getting all these demands for DSS and that's trickling back up to SPC, how has SPC stayed true to the meteorology and the science so that our probabilities are consistent, and we can do things like some of the experimental timing guidance that we're working on, and our temporal disaggregation, and our probabilistic impacts. All of that is contingent upon the probabilities being fundamentally sound. How we wrestle with the increasing DSS needs in the communication aspect that the WFO is receiving and relaying back to us, or the wanting to have a say in the meteorology, that's the kind of stress that I actually worry about for our forecasters. How are we going to handle being thrust more into an interactive role with the WFOs than what we've historically had in the past? And that's going to be the challenge for the next decade for us.
Great. Thank you, Patrick. One more hand of applause, please.